Hello, everyone, and thank you for attending today's webinar, Extend Your Reach with Location Insights. This is Session 1, Location Analytics, and the first session of our three-part webinar series. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets. All the widgets are resizable and movable, so feel free to move them around to customize your webinar experience. You can expand your slide viewing area or maximize it to full screen by clicking on the arrows in the right corner, the top right corner. If you have any questions during the webinar, you can submit them through the Q&A widget at any time. We answer as many questions as we can during the webinar. If we do not have a chance to respond to your question or run out of time, we will follow up with you via email. A copy of today's presentation and additional articles are available by clicking on the resource list widget. This webinar is being recorded and will be sent to the email you used to register within 3 business days. With that, I'd like to introduce you to today's presenter, Deanna Sanchez, Senior Technion Consultant and Alteryx ACE. Deanna, go ahead and take it away.
Hi, everyone, and thank you so much for having me today. I'm so excited to introduce you to location and Alteryx. So it's a real privilege to be here, and I'm very glad to mention that not only am I an Alteryx ACE, but I'm also a GIS professional. I have a degree in geography with concentrations in GIS and medical geography, so this truly makes me excited to be able to show you all so much of what you can do with spatial and demographic analytics here in Alteryx. So as you can see on the first slide, everything does happen somewhere, and we really are going to extend your reach with location insights today and really start this introduction of this 3-week GIS and Alteryx seminar. So here's a little bit of the agenda. I'll give you an overview of location analytics, talk about some use cases of how you really can perform location analytics. I will have to mention it is just the tip of the iceberg of what you can do with spatial analytics, especially in Alteryx. And then we're going to jump into geocoding today, and I'll explain what geocoding is and how it works in Alteryx. And then also talk about trade areas, creating those with radii and drive times, and then we'll open it up at the end for a Q&A session. So a little bit about me, as mentioned, I am a Alteryx ACE. I'm also a senior consultant at Technion Data Solutions. I started using Alteryx way back when, in 2005. I won't even let myself calculate how many years that's been. And I also have been co-leading the Dallas Alteryx user group for 5 years. And last year I founded the Fort Worth Alteryx user group as well. So we'll talk a bit about the intro to spatial analytics. So in this webinar today, we're going to talk about the basics of spatial analytics, what really is location analytics, and as mentioned, some geocoding and trade area polygons to really get you started in exploring that whole new dimension of location analytics. So what is location analytics? It is the science of obtaining insight from geographical data analysis. So you may be asking, what is geographic data? Well, it is business data such as stores and customers, hospitals and patients, distribution centers and inventory and so on. It's also demographic data. And as we get into webinar 2 next week, we're going to explore the wealth of demographic data available through Experian in Alteryx. And along with demographic data through Experian, there's segmentation lifestyle data. You may know that as mosaic data in Experian. You can also use public sector data. There's all sorts of great data available in the census.gov website under the Tiger shapefiles. And you can actually pull down boundaries of locations such as cities, census blocks, groups, and census tracts, and so on through that public sector data. But really, geographic data is anything with a spatial component. So as we said, everything happens somewhere, especially here on this planet Earth, so you can actually have a spatial component for just about anything. So to really explore spatial relationships, you can have such as ideas of a distribution center analyst, and they need to calculate the nearest stores, looking at their incoming inventory, and making sure that it's distributed evenly. This would lower the cost of transportation. It would also reduce that idle inventory. So you see here on the map, you've got about 10 stores. That idle inventory may be over-located in one of the store locations, and you may want to find, well, what are the nearest stores, and how do I redistribute that idle inventory equally among the rest of the stores? You can not only calculate this in Alteryx, but you can use a really handy tool in Alteryx called the Find Nearest tool. This tool runs extremely fast in Alteryx, as does almost everything, because Alteryx does run in virtual memory. And you can calculate, for example, the 10 nearest stores from that distribution center. And you can also analyze each store's distance relationship to other stores. How many miles away are they? How long is that drive time? How many minutes are they driving to each store? And you can do all this in Alteryx, actually. Location analytics also allows you to research boundaries. So, for example, you may have geocoded the address locations for clients of a nonprofit organization, and you've also created 30-minute drive time boundary areas for each food pantry in the Metroplex. So you may have these 30-minute drive time boundaries here in gray, and you may have stated for your volunteers they can only drive 30 minutes one way to pick up clients and then bring them back 30 minutes to that food pantry. So no more than 1 hour of driving for your volunteers. So when you geocode, you can actually place those locations of where your clients are, and then you can quickly see who's within the 30-minute drive time and who's without or outside of that 30-minute drive time. You can quickly see this in Alteryx, and this map was actually created in Alteryx as well. So Alteryx has some great mapping tools, and we will actually explore mapping on the third seminar 2 weeks from now. But we do have a great tool called Spatial Match in Alteryx. You are literally overlaying these client point layers onto the drive time area polygon layers and matching those directly onto the Earth's surface, and then using that within option to show those clients within and without. And those without may need additional transportation assistance, such as you might want to look at group transportation, for example. So again, these are tools in Alteryx that are really simple to use. And with Spatial Match, we'll be going over that next week for the second webinar. And location analytics also allows you to plan for the future, such as where do we put a new hospital? This is something I really love to do. With my background in GIS, I love site selection. And site selection is not just for retail or for restaurants anymore. You can use site selection, like in this example, for hospitals and their patients. Where do I put that new hospital or that urgent care clinic? Even nonprofits are using it. They're saying, where do I put that new location to better serve my clients? Or even cities are using site selection to say, where should I put that new library? Where do I put services that better serve my population? So the same here, where you're looking at where should we put a new hospital, you can actually calculate the average drive time of where your patients are coming from and how many minutes they're actually taking to drive to the hospital. So, for example, these catchment areas here are 20-minute drive times. You may look at patients that are outside of those 20-minute drive times and decide, I may need to put a new location here, maybe at this intersection for better ingress and better accessibility for my patients. And looking at all these patients here who are underserved and driving more than 20 minutes, maybe we can put a location here that better serves them. So site selection really helps you not only optimize your current locations, but as it shows on the slide, and for the future. We'll cover a bit of that on the third webinar of this series 2 weeks from now. So as I mentioned, everything does happen somewhere, especially here on planet Earth. And the first step really to figure out your data for location analytics is geocoding. So what exactly is geocoding? It's really adding a latitude and longitude geocode to standardize addresses. And I'll actually do a demo of that today, and you'll see that actually happening on the fly. So first, for those who are really new to spatial analytics, I did want to explain what latitude and longitude is. Latitude is a measure in degrees proceeding north or south from the equator. So latitude are these lines going across the world, and as you go up from the equator, latitude increases. So Texas is about 35 degrees latitude, and I am from Texas. That's why I like to highlight Texas there. Longitude is actually a measure in degrees proceeding east or west. So it's these long lines here going up and down from the North Pole to the South Pole. And they proceed east or west from the prime meridian, which is at 0 degrees, extending through the Royal Observatory of Greenwich, England. And the reason that it's there in the Royal Observatory of Greenwich, England, I could actually do a whole webinar on that. But I highly recommend that you look up Wikipedia and learn about longitude. There's also a great book by Dava Sorbel called Longitude. And it really explains a lot of that process of how longitude was really developed, especially for navigation by ships. And it really did change the world, literally, especially our economic markets in the world and so on. So if you'd like to learn more about longitude, there's some great resources out there. So this longitude and this latitude actually create those X and Y coordinates for location on the Earth's surface. So that's geocoding. And when we use geocoding in Alteryx, we're actually using an engine provided by Tomtom data. And Tomtom data is extremely robust. It's updated every quarter in Alteryx. And that way you have not only the latest information, but you have great information for those high growth areas as well with the Tomtom data. So that's actually one of the great benefits of Alteryx in geocoding. So we'll look at geocoding in action today. And the use case very often used for geocoding is, say, for example, major retailers. They probably receive a customer spreadsheet of customer names and addresses, and they want to display those on a map, but not only display it on a map, they want to understand the spatial interactions between those customers and stores, even competitors, and so on. So once your data are geocoded, you can ask more questions, such as, how far away are my customers from the stores? That's a really good question to ask in retail. So you want to know, how far are they driving, and is this different in an urban area than a rural area, and so on. How many minutes are my customers driving, especially during peak traffic? So you'll see in the demo today that Alteryx allows you to change between drive time types of peak traffic, off-peak, and even nighttime traffic conditions. So again, another great advantage of using Alteryx for geocoding. Another question you could ask are, what are the average drive distance for my customers? Like you saw in the previous slides of hospitals, and are they driving on average more than 20 minutes? And another question is, where are most of my customers clustered, in order to designate trade areas? So we'll go into trade area development today as well. And trade areas are really essential, not just in retail, but again, as you saw, for hospital patients and so on, really to understand anyone who uses your services. It's really important to know how and where are my customers clustered, and what are those things that are affecting those cluster factors. Why are they clustering here, and why are they not clustering over here? And again, another question is, what are the nearest 3 stores to each customer? You may want to optimize your store locations. You may want to relocate a store. If you relocate one store, where are the nearest other stores to those customers, so that I can market appropriately to those customers and let them know what other stores they can actually access. And then another question is, are there areas where customers are driving a long distance? Could I place a new store there to serve them more efficiently? And that goes into that site selection process, which we'll talk about on the 3rd webinar. So lots of questions you can ask once your data are geocoded. That really is the start of all data, is really getting that X and Y, that longitude and that latitude, to figure out, where is this happening? Now, can I ask those questions about it? We'll also look at trade areas. So trade areas are typically a polygon around a certain point. such as a drive time around a store and so on. And on the left, you see radius rings. So radius rings have been utilized for many, many years. You've probably heard of a 5-mile radius or a 10-mile radius. And these are based on straight line distance, or as we say in GIS, as the crow flies. They're really easy to generate. They're a simple shape. It's a circle. Because it's a circle and it doesn't have very many segments, it's a smaller file size. So this does actually generate very rapidly in Alteryx, as it would in lots of other geographic software. You can overlay everything with a radius. So that's one aspect of radii that I will differentiate when I talk about drive time polygons, is that it overlays everything: oceans, lakes, mountains, airports, everything. So if you're looking at population within a 5-mile radius, understand that that population is also taking into account this lake here, and hopefully there's no one living in that lake, so that you may not be looking totally at the population of where everyone's coming from. On the converse, there are drive time polygons. So you see here on the right, I have a center point, for example, maybe a store. And then I have this drive time polygon that's generated, and it's really based on the time it takes to drive along a street network from one point to the other. So as mentioned, the geocoding engine is Tomtom data. The same for the street networks in Alteryx. It's Tomtom data, and it's running that street network in the drive time analysis, and it's actually calculating from this point along all of the streets in the network: residential streets, arterials, even highways. And as you can see, it's starting to extend along the highway when it creates the drive time. And that's because every street in the drive time network actually has a speed associated with it. So residential streets might be 30 miles an hour, arterials might be 45 or 50 miles an hour, and then highways are 60 to 75 miles an hour, for example. So theoretically, you can go faster and farther along a highway. That's why it extends along those highways there. So with a drive time polygon, this edge denotes, in this example, where you can go in 10 minutes from the center point. So theoretically, from the center here, you can reach this boundary in 10 minutes. And so that's really how drive times are created. It's looking at distance and speed along those networks and then creating that polygon. These are really nice. They do take a bit longer to generate because it is reaching out through this entire street network. However, in Alteryx, it's still blazingly fast because, as mentioned, Alteryx runs in virtual memory. It is a little bit larger file size because these are segments here. So every curve and turn here consists of a segment in the spatial object. And then it does consider mountains, lakes, and other geographic boundaries. So this will actually drive around a park and around a lake and around an airport, for example. And with drive time polygons, you can more accurately see where your customers are coming from, where they're driving from, how long it's taking them to drive, and so on. There's great use for radius rings, but there's also great use for drive time polygons as well, especially when you know where they're driving from. Then drive time polygons are essential. And then at the end, we'll go into a Q&A. But long before that, I'm going to dive right now into Alteryx and actually show you geocoding and trade area generation in Alteryx. So go ahead and share my screen here. And I do have Alteryx up. And for those of you who are really new to Alteryx, this is Alteryx. It is a fantastic tool. As you can see, I've been using it since 2005, so it is one of my most favorite tools out there, most favorite software platforms. It has a really great GUI, or graphical user interface. It is drag and drop. So I can click on a tool, such as this input data tool, drag it to the canvas, and then I start building my workflows on this canvas here. So every tool that I drag to the workflow has its own configuration. So my configuration window here on the left will actually change based on every tool that I bring to the canvas. I also have a workflow configuration, So I can click anywhere on the white space, get to my workflow configuration and have items for that as well. And you can see up here, I've got a lot of tools. So all of these tools here with the gold star are my favorites tools, but I also have a wealth of other tool sets that you can use inside Alteryx. So not only do I have a lot of in and out tools, but a huge amount of preparation tools. And Alteryx has been widely known as a data prep and blending tool, but that really is just the cornerstone of the foundation of Alteryx. There's so much more to Alteryx than data prep and blending. So as you can see from the tools up here, there's join and parse and transform, but I also have in-database connections. So I can actually connect inside a database and perform joins and filters and sampling in the database as well. Alteryx has some great reporting tools where you can not only create charts and so on, but you can create those maps that I showed earlier. And you've got some interactive chart tools and Insight interactive dashboard tools as well. We'll also go into some spatial tools. So this green tool set is one of my favorite tool sets of all. And as we work it through these tool sets in week 2 and week 3, you'll get to know a lot more of these tools here. But as you can see, we also have a lot of other options. So we've got predictive tools in Alteryx. You can see there's linear and logistic regressions and so on. There's also time series. And we have predictive groupings such as k-means, cluster analysis, and also prescriptive such as optimization and simulation as well. So again, data prep and blending is just a tiny cornerstone of all that Alteryx can do. There is so much more. So we'll get into addresses today and demographic analysis next week with the Experian data. But first, I want to go back to those favorites tools, and I want to show here in our tool set, I've got a file input tool. I'm actually going to navigate to just a CSV file, and then I'm going to geocode it. I'm going to show you some of the great benefits in Alteryx of geocoding. So here I'm going to connect to a file or database. You'll notice this input data tool now has its own configuration. I'm going to click on that drop-down and click on File. But before I do that, I wanted to show you, you've got options for SQL Server, Oracle, Hadoop, even ODBC, OLEDBs, and even Esri connections for geodatabases for those who are Esri users out there. I've been an Esri user since 1997, I guess the last century, so I'm a big fan of Esri and MapInfo as well. But I also love Alteryx, so we can really do a lot of cool spatial stuff that you'll see today in Alteryx as well. So I've clicked on File, and now you can see I can navigate to open a file. But first I wanted to show you the many file types you can actually access and connect to in Alteryx. There's a huge amount of connectivity available. As you can see, we've got not only CSVs, Microsoft Access, and Excel, and so on, but we've got a wealth of spatial options you can connect to, such as Esri shapefiles, MapInfo tab files, even Google Earth KML files you can connect to. You can also output in these formats as well, along with connecting to SAS, SPSS, and so on. And for your outputs, you also have Tableau. For those Tableau users out there, there are outputs for Tableau.tdes, or Tableau data extracts, and Tableau Hyper also. But for now, I'm going to click on a CSV. And I want to bring in a data set just called Customers for Geocoding.csv. So you'll see when I bring in the data set, I get a nice preview of the data. So here I've got a customer ID, a store number, a segment, whether they're responding, say, to a mail out, and then some address information. So this address information is what I'm going to use to geocode. So it is essential in the geocoding process to have my address, city, state, and zip in 4 different fields. If you don't have your data in 4 different fields, say it's actually concatenated with a comma, you can actually use address parsing tools. So Alteryx has these address tools here in the address toolbar, and you can actually parse your address out. You can actually take parsing tools also here. Got a lot of great parsing tools. We can just do a text to columns and use a comma as a delimiter. So there's a lot of options for parsing your data. But going back to that address tool set, there's actually something very cool that you can use in Alteryx, and I use it every time I geocode. So you see that I've got my file here. You can see my file path. If I click up here at the top, customers for geocoding.csv, if I click apply, which is this little button down here on the bottom left, it notices that now it's applied and the file is loaded. There's something that I can use in Alteryx called CAS, and this is the Coding Accuracy Support System from the U.S. Postal Service. This is extremely useful. This will clean and standardize your data long before you geocode it. So this actually looks at your addresses and it performs a lookup against a table for CAS, and it standardizes those addresses and finds the right zip code, cleans and creates the right address, and so on for your data. So I'm actually going to pull in the CAS tool and see how I actually connect it. So you notice when I dragged and dropped, I'll actually delete this and do that again just to make it easier to see. I can actually pull and connect tools, and you can see a dotted line form here. And now that tool is connected to the input tool. So as you see me work on these workflows, I'm going to connect a chain of tools. And the really nice thing about Alteryx is this transparency. Every tool that I bring to the canvas, you can see the configuration for it, and you can see exactly what's happening tool by tool in Alteryx, step by step. So in Alteryx, you're not creating those, as they say, black box, models, where you don't really know what's happening inside of that model or that regression or so on. You can actually pull it in here and see step by step exactly what's happening every step of the way in your workflow and make changes in that workflow for every single tool. So it's one of the huge benefits of Alteryx. You can see here now in my configuration for CAS, I've got an address field. I do have an option for an urbanization field for Puerto Rico data, a company field if needed, address to. I'm not going to use those since I don't really have that in my data set this time. But I do have a city, state, and zip. So this is why those 4 fields need to be separated so that the tool can find those fields and utilize them. I'm going to now go to what's called a browse tool, and this is one of the most favorite tools of all for a lot of users in Alteryx. I'm actually going to add this browse and simply browse my output. I'm not actually creating an output. I'm not creating an Excel file or anything like that. I'm just creating a temp table to where I can browse my data. And you can see, I actually clicked run, and you can see how fast that was, just casting the data. 2.3 seconds, which was really nice. So again, my run tool is here. I can click run workflow. For me, it's a lot like a video game. You just click that play button there, and then it runs. It casts the data. It tells me how long it ran. You can see in the results window, it's telling me step by step what time it started running, where my data is coming from, what's happening for every single part of the tools, and then the browse data. So I'm going to click on this browse, and not only do I get to see the data here in my results window, but I get a nice preview of my data here on the left with the browse tool. I can see how many are null or empty. These are 100% okay. I can even go and look at how many have trailing or leading white space and so on. So with every browse tool and you look at your data, you get this nice preview of your data as well. But something I wanted to show you, I'm going to open this browse in a new window. And now you can see all of the data. You can actually browse even 1 million records in a browse tool and more. So you can see here, I've got a little over 2,000 records here. I can actually browse all the way to the last record and look at the data. So it's really flexible using this browse tool. Again, it's just creating a temp table. And just wanted to mention, Alteryx doesn't store data. It actually points to your data, but it does not store data. So it's not a database, but it does point to and connect to all of those options that I showed earlier when I was connecting to a file. So here you can see my original data with that address, city, state, and zip. And now you can see the CAS data. So you can see this is based on the lookup table for the Postal Service. I can actually see what CAS is saying, including its results. There's a code there for the results. I also did another webinar way back, so if you'd like to look on the Technion website at technionusa.com/events, you can actually look at the data and actually see the geocoding webinar for that as well under resources. So here it's adding these fields for CAS. So this is what's been cleaned and standardized. Now that I've cleaned and standardized my data, I can geocode it. So I'm going to go back to address, and then I'm going to use a street geocoder. So again, as mentioned, it's going to add those coordinates of latitude and longitude to every address, and it's going to create a spatial object at the same time. So I'm going to actually pull this in. Now that I've cleaned and standardized my data, I can use those fields, the CAS address, CAS state, and so on, to geocode. So I'm going to add this street geocoder. I have options for how I want the data to come out. Do I want to use the spatial object? Do I want to see the latitude and longitude, the geo level, and so on? So you've got a lot of options here where you can actually use that CAS data. And then I'm going to go into a browse so you can actually see what happens when I geocode the data. So when I geocode, the street geocoder will prompt me which one is the right address. So this one I've got an Adams Street and I have a South Adams Street. If I'm geocoding a lot of records, say a few million records, and I don't want to manually go through each of these one at a time, I can click on First to All. And it's just going to click on select the first result for each one of those and use that as the geocoding result. So 23 seconds for almost 3,000 records. That's really great. Now I've got my output here, and I also have a spatial object. So to see what that looks like, these are the CAS fields that were added. Now I've got a match status of exact, a score of 100. It matched exactly to the street level, and a latitude and longitude here. So now you can see those lat and long fields. Those are those X and Y geocoded coordinates, and my geo level of street. I'll explain a little bit more about geo level in a moment, but I also wanted to add there's a census ID. So I can actually use this FIPS code, or Federal Information Processing Standards code, to actually match the census ID, say, to a block group or a census tract or so on. So in the geocoding process, Alteryx actually adds that as well. But the cool thing is now I have this field of spatial object. So Alteryx does store spatial objects. As it processes the data, it will actually create a spatial object in the data set as well. It will create points, polylines, and polygons. And as we go into session 3, we'll actually create a lot of those on our own. And I can show how that works with that more advanced technique of creating your own points and polygons manually. But with geocoding, you have a point as well. This field of spatial object is what's being used here in the display to actually overlay all of those customer points onto this map of Denver, Colorado. So it's really a neat feature where you can actually store the spatial objects with the rest of the data set, and you can have more than one spatial object in the data stream in Alteryx. So you're not limited to only a point here. You'll actually see next week when I do Spatial Match, you can have a point and a polygon and so on, all in the same record. So it's really a huge benefit of Alteryx also. So now that you've seen what this looks like with the spatial object, I'm going to actually use another geocoder. So this is one that I really love to use. It's the US Geocoder. This actually wraps in together CAS, where you clean and standardize your addresses, along with street geocoding, and the US ZIP9 geocoder. So if your zip codes have that dash and those additional 4 digits, which is normally called ZIP9, you can actually geocode to that level as well. And this is great to use if the geocoder cannot find your address, but you have that zip code. So I'm going to use the US geocoder. I'm going to bring this to the canvas, and I'm going to move this browse tool up just to save space. And then I'm going to connect straight from the data input source. So I'm going to geocode these as well. But now you can see I've got 4 tabs here. I've got a tab for input, where I can navigate to my fields for address, city, state, and zip. 4 fields. And then I have my Geocoder options. Again, it's using Tomtom here for my Geocoder. I can actually change multiple match from prompt to select to just choose first to all. Whenever it's an East Hickory Street or a West Hickory Street, just choose the first one and geocode it. And then I have my options here. So I'm going to actually add all browses. So I'm going to do a little quick tip and trick. I'm going to right-click on that tool and add all browses. So now I've got 2 browses here. G is for the geocoded results. S is a summary of the geocoding process. So I'm going to run this, and you'll actually see what happens. So I've got that first all for that very first geocoder here. But now this second geocoder is running. Again, that's really quick. I've just used 2 geocoders, and it ran at 8.6 seconds. So here's my geocoded output. Here's my address, city, state, and zip, the rest of the data. It cast the data, or it standardized the data, the addresses. And then I can look and see what happens after that. I've got a match status, my spatial object, my latitude and longitude, my geo level, which I'll talk about in a moment, and then zip9 data. So if there were zip codes with those -4, it would geocode to that level if it couldn't find the address as well. So this is all my geocoded data, same as when I geocoded here, but I really like this summary output because this summary actually tells me how well it geocoded. So out of all of the data, 2,667 geocoded to the street level, 1 was extrapolated, and 10, it didn't find the address by the street address, so it found it by the zip code. So the neat thing is, in geocoding, it's actually not taking the point and placing it directly on your rooftop or on your front door, for example, when it's finding an address. What it's doing when it's finding a street address is it's actually interpolating along the block numbers of a street. So, for example, if you have a street address of 500 Main Street, it's actually going to look at 100 Main Street to 1000 Main Street and place that point in the middle of the street around 500. Most of the time that's going to be really close to, say, the house, for example, but it is a good thing to note that in geocoding it is not an exact science. It is not putting that point on your doorstep. It's really just looking along the street according to the block number, and then it's saying between 100 Main and 1000 Main, this is where a 500 Main would be. So that's actually how geocoding works. It's actually geocoding here at the street level. There's an option for actual geocoding, and that's using Parcel geocoding, where it does place it in the center of the parcel. And that's an additional option in Alteryx. Again, it's not doing it right on the rooftop. It might be if that house is in the middle of the parcel, but you do have parcel level geocoding. But then we have extrapolation, where if it didn't find the address, say it was out of the block range for the street, it will find and put it close to the nearest block. So if the block starts at 100 Main Street, but your address is 50 Main Street, it will put it at 100 Main Street. So it's going to extrapolate and find the nearest one if it's out of range. And then if it can't find the street address, then you do have your zip9 coding, and it will put it at the center of the zip code. Or if you have that -4 or even -2 digits, it will find it to the zip9 or the zip7 level. So that's a little bit about geocoding. Again, I've done a webinar that really goes into geocoding, and I'll post the link on that at the end of the 3 webinar series as well. So with this geocoded data, you can actually output the data. So I'm going to go back to my favorites tools and use an output data tool. I'm going to just bring it here to my geocoded data set. And I'll just move this browse tool, make it a little seamless there. And I'm going to connect my geocoded data to the output data tool. So just as you saw with the input data tool, I can connect to a file. I can also connect to a SQL Server, other databases, and so on. But with this file, I can actually click on File, and I can actually create an output file. So here's, as I mentioned, for the Tableau users out there, there's .td and Hyper. I can actually change it to an Esri shapefile, and I can actually output a spatial object as a shapefile for use not only, again, in Alteryx, but in other software, such as GIS software, as Esri, or even MapInfo. There's tab file options for export as well. So I can actually create a shapefile. So I'm going to call this customers and leave it as a shapefile here and click Save. And the nice thing is with the shapefile, I can choose my spatial object. So as I mentioned before in Alteryx, you can have multiple spatial objects. So if I had a polygon here as well, I can choose which one I'm outputting. And then I can just say Run, and then it outputs the customer shape. I'm going to say First to All for that first geocoder there. It's going to continue to geocode and then output the shapefile. It's going to tell me with my output data, 2,678 records were written to now a shapefile. So I also can output to another format, and this is a great format to use. It is an Alteryx YXDB. So I'm going to change it from a shapefile, and I'm going to output it to an Alteryx database. And with this Alteryx database, I can actually call it Geocoded Customers. I'll click Save. And then I'll apply, and you'll see the name change. And the benefit of using a YXDB is this is the native format for Alteryx. So not only does it run seamlessly in Alteryx and optimize the data, but you can actually use this in other workflows, and you can store more than one spatial object type inside of this output. So that's one reason I like to use YXDBs, is I'm not limited to just a point or just a polygon. I can have both. I can have a line in there as well, and it'll all stay inside of this YXDB or Alteryx database. So this Geocoded Customers will actually be used in next week's session. So I'm outputting this database, and then we'll use it for next week also. But at the end of the 3 webinar series, the listeners on this webinar will actually receive a copy of the data for use and practice yourselves. So you'll actually receive at the end of the series and some instructions on how to use this data, along with some other data that we're generating, so that you can go back and utilize this data and follow along and really learn and explore those spatial tools in Alteryx. I did want to add one more option here. So if you have data that's already geocoded, so I'm going to bring in an input data tool. I'm going to navigate to a file again. Here's my data file. And I'm going to navigate to customers with lat long, CSV. It's just a comma separated values file, just a text file. But this data actually has latitude and longitude already in it as a field. So some of you may already receive your data that way, with latitude and longitude already pre-geocoded. If you do, you don't actually have to geocode. You don't have to use this Geocoder tool. You can actually use a Create Points tool, and it is a really simple configuration. So I'm going to bring Create Points here. It's going to automatically find my longitude and my latitude fields, and then it's going to create that spatial point with that information. So I'm going to add a Browse tool here. I'm also going to do something really cool in Alteryx. You noticed here every time I run this, it's going to do First to All. I'm actually going to take these tools, right-click, add them to a container, and with this container, I'm actually going to disable this container. So I can click here, disable the container. It's not going to run. So while I'm actually running this data, the container is now disabling that portion of the workflow, and it's not going to run and prompt me for First to All. So you can actually containerize portions of your workflow, and that really makes things very efficient, especially when testing large workflows or testing data. You can actually put it in a container, and you'll notice this portion didn't run, which was really efficient. So here I've done Create Points, already using that latitude and longitude. Now I've got a new spatial point here, a centroid that's been created using that pre-existing latitude and longitude. So I wanted to add that if you do have data that come in that format, you can actually use it without geocoding. So the next thing I want to show before we get into spatial or into our question and answers here, I want to actually show some trade area. So I'm going to bring in a shapefile, and I'm going to connect to a file, and this is actually stores.shape. So you can connect to Esri shapefiles. You can see here I've got just 10 stores here, very simple file in the Denver area, and a spatial object field. So I'm going to add a browse to that so you can see what this looks like. and quickly run. And so you can see all of the data going through, and there's those 10 stores in the Denver area. And you can see little points here on the map. Anytime I'm using spatial data, a best practice is to use a browse tool so that you can browse your data and get a nice map in the background to actually look at your data. So now that we've seen what the stores look like, I'm actually going to create a radius trade area. And to do that, I'm going to go back to my spatial tool set and click on the trade area tool. So I'm going to bring this trade area tool to the canvas, and you can see the configuration changes. Now I've got a spatial object as my point source. I'm going to keep it in the output, and very quickly I'm going to leave it as a default 5 here and create a radius of 5 miles. You do have options for kilometers as well, and in a moment we're going to explore the drive time minutes with the Tomtom dataset, and also we're going to explore whether or not to eliminate that overlap. But before I do that, I'm just going to add a browse tool here and click Run. So you can actually see what this looks like when you create a 5-mile radius. That was 3.2 seconds, and it's making 10 radii around each of these store points. So here you can see the store points, and in the map I can click on each one of these, and now you can see the radii around each of these store points. And you can see in my data set here, I actually have the store point and the polygon trade area associated with that store point all in the same record. So I could output this as a YXDB and keep it exactly as it is with the store point and the polygon for each record. I even have my radius size here. So the next thing I'm going to do, now that you've seen what radii look like, I'm actually going to go back to this trade area tool, and I'm going to do eliminate overlap. So you saw how the radii, some of those overlap each other. So these are definitely overlapping radii. What if I wanted to create individual areas that do not overlap with any other and have individual trade areas for each store? I can go back to this and simply click Eliminate Overlap. And it is only available for the specific value radius only, and not for the drive time, at least in this configuration for this tool. I'll show you drive time in a moment. Now I'm going to click Run, and you'll see it iterate through. It's geocoding over here. And then a little over 3 seconds, it eliminated the overlap. And now I'll actually turn off the map so you can see this a little easier. I'm going to say no base map. You can see the wealth of other map options available, including the dark matter or those kind of black background base maps, which are really cool. I'm going to click on no base map, and now you can see the overlap has been eliminated. There actually have become bisecting areas here, so whatever is equidistant from each point, it actually bisects that radius. So between 2 points, it's going to find the equal distance and then bisect that radius. So now I've got non-overlapping radii. And you saw how quick that was in Alteryx to actually do that. I simply checked a box to make that happen. So that's how you create radii in Alteryx. Again, it's really simple to do. I'm going to actually allow the overlap now, and I'm going to go back and I'm going to change this to 10, and I'm going to make it 10 minutes. So I'm going to do a 10-minute drive time using Tomtom data. So as I mentioned earlier, you can do off-peak or say Sunday afternoon traffic. You can do night, or you can do peak or rush hour traffic. So I'm going to do off-peak, just say that it's a nice after 5, really after 7 p.m. in Dallas traffic situation there. And then I'm going to click Run. So it's going to actually iterate through each of these 10 stores and generate a drive time for all 10 of those. You saw how fast that was. It's actually generating drive time. It just added 1 more second to the process. And now you can see the drive time areas here. So for each one of these, now I've got a drive time for every single one of my store locations. It ran along the Tomtom network. I'm going to actually pull up that map there. And along these street networks, and found what is the 10-minute boundary from this point to the edge of this. So it theoretically, in non-peak traffic, you can go from here to here in 10 minutes. So you can see here that these are overlapping, but as I mentioned, with drive time, it does not have to take into account those lakes and those parks and so on. So this drive time for this store trade area now does not include this park and this lake. It simply includes this drive time area and extends along the highway, since you can go faster along highways, theoretically, especially in off-peak data. So you may be wondering, okay, how do I make non-overlapping drive times? So the really nice thing you can do here is in Spatial, there's actually a non-overlap drive time tool. So as the last part of this series or this webinar today, I'm going to bring in a non-overlap drive time. I'm going to pull in my stores directly to this. I'm going to say, give it a 10-minute drive time. Keep it as off-peak, even though I have night and peak options. And I'm going to change my grid size to 1. And this is important. I'm going to make a 1-mile grid for every time it bisects in between the drive time trade areas. And you'll see what that looks like. The larger the grid size, the less segments I'm creating, and the faster it runs. So I'll show you what that looks like with a 1-mile grid and then with a 1/4-mile grid. So it's actually creating these. Now you can see, I'm going to take the map off here. Now you can see these are non-overlapping drive time. And as I zoom into the grid, you can actually see now between 2 points, it's actually creating a little gridded segment here. So this is a 1-mile grid. So this little segment here is 1 mile. And in between these two, it's just saying create a 1-mile segment that actually bisects between the two. So if I used a 1/4 mile, I will have a much more granular grid size, and it'll take a little bit longer to run. So I'm going to change that grid size to a 1/4 mile, run this. It'll take a few more seconds for it to iterate through and create those grids. But then you can actually see what happens with the grid size. Again, this is blazingly fast. That's 7 seconds to generate the grid size here. And now I've got a 1/4 mile grid in between each of these. So I've got a much more fine granularity between each of these grid sizes. So wherever it's creating those grids, it's doing a 1/4 mile now. And, it adds a little bit more data because it's creating more segments, but I have a better granularity. So I also may want to output this so that we can use it next week. So what I'm going to do is go back here to my drive time. I've got my 10-minute drive time minutes here. I can see my data. I want to use these as my store trade areas for a spatial match next week. So you can see we've got customers in the Denver area here as well. And then we have our store trade areas in the Denver area also. Next week, we're going to do a spatial match on those. I'm going to show you a best practice before you output spatial data. You can see here I've got a spatial object and a spatial object trade area. I'm going to add a select tool. And with the select tool, you can actually do all sorts of things, such as change your data types and so on, change your sizes. But what's really nice is you can rename. So a best practice is to rename your spatial objects. So I'm going to change this to store spatial object. It is as easy as typing to rename. It's that simple. And then I'm going to take my trade area and just call this trade area spatial object. So I'm renaming this field, and this is going to create a field name that persists throughout the rest of my workflow. It's also going to persist in my output. So now I've got this output. I can create an output data file, and I'm going to call this one stores and trade area, YXDB. So I'll just keep it as a YXDB. Stores and trade areas there. And you can see when I output it, it's not asking me which spatial object do I want to output. It's going to keep both in the output. So with this, I'll run this. You'll see what the data look like in the output. Again, this is less than 10 seconds for this all to run. It's geocoding, it's creating drive times and so on. It's still blazingly fast. And this is what my output looks like. I've clicked on the end of the select tool, got a store object, a trade area spatial object, my radius size, and now it's a YXDB that I can use in other workflows, such as we'll use next week. Before I turn it over for Q&A, in the interest of time, I wanted to quickly show you an option up here. You can actually search for tools up here. So if you're really new to Alteryx and you're looking for a tool such as the Find Nearest tool, you can actually just start typing, and it gives you a global search. So not only do I see where my tools are and in what category, which are color-coded, I also have help that comes up with this. So I can actually click on help, learn about the Find Nearest tool, or even in the Alteryx community, which is a wealth of information. Not only are Alteryx staff posting assistance in the community, but people around the world, Alteryx users everywhere, are posting in the community and helping others throughout this community knowledge. So you can actually click on Community and learn Tool Mastery about Find Nearest and so on. So all of that is here in the search bar in your global search here in Alteryx. So I wanted to go ahead and wrap this one up with this quick introduction to geocoding, finding your place, and then creating those trade areas. And wanted to open it up for Q&A, but also wanted to mention next week it will be Spatial Match and getting into the Experian data. And then at the end of this 3-week seminar, you will be receiving these data sets so that you can use them as well. But again, I'll open it up for Spatial Match also, or Spatial Match, I've got that on my mind. Open it up for Q&A also.
Thank you, Deanna, for that fantastic presentation. We do have some great questions from the audience. So let's kick it off with, do you need all the input fields in order to geocode, as in address, city, state, postal code?
You do for the most part. That's a really great question. If you have CAS, so with CAS, it really is helpful to have your addresses, but for example, if you're missing zip codes, CAS will help you locate many of those zip codes and so on. But it really does help to have all 4 of those fields available. So for example, if you had 100 Main Street but no city, there might be a lot of cities inside of your state that have 100 Main Street. So it might be difficult to find the city and state with that. But if you had 100 Main Street and a zip code, say 76201 for Dallas, you probably could find the city and state for that because you have the zip code. So it is best to have as much data as possible, but CAS will help you find that.
Great, thank you. Another question, Deanna, can you show again how to find the Parcel geocoder?
Yes, for the Parcel geocoder, there is an option here. So I'm going to pull up that US geocoder under address. So there is a US geocoder. There are options here, Tomtom Multinet address points. So this is another installation, so it's important to talk with your Alteryx rep on this, but you can use the Multinet address points. And that really does get it not only to the street level, but it'll bring it to the actual level there. Again, it's not placing it right on your front door, but it is really, really close. It will get to the parcel level or multinet through Tomtom data as well. But again, it's good to talk to your Alteryx rep about enabling that multinet address point license.
Great, thank you, Deanna. And then can you explain when someone would use the street geocoder versus the US geocoder?
Yes, absolutely. The US Geocoder I really love, mainly because it has all of this wrapped into it. It's actually a macro, so you can create macros in Alteryx and wrap them into tools. And this is actually a macro that takes CAS plus the street geocoder plus the zip9 coder and wraps them all into one tool. So if you want to use all of those options, I recommend using the US Geocoder tool. But if you simply want to do, as in the first container here, you just want to cast your data first and then use a street geocoder for the US, you can actually just use those two. Just cast first, which I highly recommend to clean and standardize your data, and then use that street geocoder. So if you're not wanting to zip9 that geocode, but then you don't have to. CAS and Street Geocoder are just fine.
Great, thank you, Deanna. Another question, is it possible to generate lat and longs from a data set that has only on street and 2 cross streets?
Okay, so kind of like looking at an intersection. kind of like saying it's at the intersection of one street and a couple of cross streets. I would say that's a little more difficult. I think it would try to find it at creating that intersection there using the US Geocoder, but if you don't have the actual address information, that is a little more difficult to actually accurately geocode that data.
Great, thank you. When we cast some of the records, somebody is saying when they cast some of the records, they are not coded. What can be possible reasons for that error?
I've actually seen that many times before, and that's a really good question. That means that it's not finding it according to the U.S. Postal database. So sometimes there are addresses that might be fuzzy, as I'll call them that. It could be such and such mall, for example, as the address, and that's actually not a standardized address according to the Postal Service. So it usually will skip that address and say, nope, I'm not going to try to geocode such and such mall because I don't actually have a street address for it. It also could be an address that is incorrect or that doesn't have all the information. So it may have the name of the street, but it may not have the street type, such as street or highway or parkway and things like that. CAS really does a good job of finding most addresses, though, a really high percentage of addresses. So if you do geocode in finding CAS that there's not a geocoded result, it's good to filter on that using the filter tool here and filter out all those addresses that did not geocode and then really explore them and start asking why those didn't geocode. Sometimes it's based on data error. You know, the address is not complete, for example.
Thanks, Deanna. And unfortunately, we have run out of time, so we'll take one last question to ask you. Now, does Alteryx have the capability to geocode outside of the U.S.?
It does. There's actually Canada, so you can actually obtain data for Canada for geocoding. So you can use it with that. There are other options with other software for geocoding outside of the U.S., but Alteryx does have U.S. and Canada as well for geocoding.
Wonderful. Thanks again, Deanna, for this fabulous presentation. Just want to remind our audience, that Session 2, Spatial Match and Distance, takes place next Wednesday on July 24th. So this now brings our webinar to a close. Thank you all so much for attending today's session, and have a great rest of your day.
Thank you very much. I look forward to next week.